Hello everybody, my name is Antonio Ruiz, and this is a video for showcasing my teaching capabilities for the TA position at the University of California, San Diego. Today, I'm going to talk to you about the gradient descent algorithm, so let's start with this. What is the gradient descent algorithm used for? So the gradient descent algorithm is used for try to find the minimum value of a function in an iteratively way. Okay, why we use this? Because sometimes, especially in machine learning, what we want to do is we want to be able to update the parameters of our model automatically in an iterative way so we can get the less error that we can. Okay. So let's explain a bit more about this concept. So first of all, let's imagine that you have a data set, right? You have a data set of points and you want to fit a very simple model that is just dependent of one variable. This parameter can be, for example, the parameter theta, and your model can be just a simple linear model, right? You need to define a cost function in order to measure if the current value of your parameter theta that you're using for the model is making good predictions or not. In that case, we are comparing the predictions with the actual value, and we are squaring that in order to to get a measure of the error that we are making with this model, right? So our goal is basically to minimize these errors so the predictions are very close to the actual values, right? And for that, what we need to do is we want to be able to find this optimal value of our parameter theta that will provide to us the minimum error, right? So what the gradient descent algorithm does for this goal is as follows. First of all, it picks just a random value for our parameter theta, right? This will be our theta 0. And then what it will try to do is it will try to pick first a direction, and it will move some distance in that direction in order to update this parameter. And we expect that for each iteration, we are going to get a better parameter for theta that will reach out close to this optimal value of theta. So as you can see here, there are two main components for this algorithm. One of them is at each point, what we want to know is what is the direction that we should move on, and also what we want to know is how far we should move into that direction, right? So how can I get the direction that we should move on? Well, basically, we can use the gradient of our error function over our theta parameter to try to find what is the direction that is providing to us the maximum amount of decrease of our function at that particular point, right? Remember that the gradient is just the slope of a tangent line to that particular point of our function. So we can use that to take a sense of the direction that we should move. And how can we decide how far we should travel into that direction? Well, that's why we define a learning rate in our algorithm. So this learning rate is basically just a factor that is going to be multiplied by this direction where we should be moving our parameter. So basically, what we are going to do at each iteration is we are going to set the new value of theta equal to the previous value of theta minus that step that we want to travel around the direction and the direction itself, right? And then what we're going to do is we're going to repeat this process over and over until this error value basically is not changing in a very relevant way. Okay, so that is in a very high level explanation how the gradient descent algorithm works. I hope this is helpful. Thank you very much.